Hello, in this video, we're going to talk about is some things that we're going to need that we haven't learned about yet for our next performance task. I really wanted to create a meaningful task for you guys so that you could see something that's real, true data. So you're going to be doing some things with college tuition. But there were a couple to make it real. We had to talk about regression lines and R-squared values. You're also going to be doing things in some spreadsheets, which is part of the standards actually. But this is just to help us understand these calculations that we're doing and what they mean, so you can answer some of the things on the task next week. So first of all, a regression line. Possibly you've seen this somewhere along the way, but sometimes this is something that gets cut out. It's basically a line of best fit. It can be another type of equation, meaning it doesn't have to be linear. It could be parabolic, it could be exponential, it could even be trigonometric. So it can be any type of equation that fits the data. In our case, we're going to stick with a linear equation of best fit. We can also use that line of best fit to actually predict results of the future. So once you've got enough data, you can predict something that's the next year out, or 2 or 3 years, or 10 or 20 years down the line. It's what insurance companies use to predict things about how much they're going to charge you. They use regressions. So to use a regression line to predict values, you have to, so here's part of my performance task that I practiced, and I was able to calculate this regression line right here. It doesn't say y equals, but that's okay. We know it's a y equals line. So this is my regression equation right there. Then in order to use it to predict things, I was told I had to predict what happened in year 11. My data went to year 10. So all I have to do is take that prediction year and I have substituted into the equation, and then I get my prediction after I do my calculation. So that's how you would make your prediction. Then the next thing we have to know is how good of a prediction that is. How close are we? So this is what we call the R-squared value. The R-squared value is basically a percentage used to determine how good our model or regression line is. So the closer to 100%, the more accurate the prediction is going to be. So when companies or insurance companies are making these predictions, they try to get this equation to get that R-squared value as close to 100% as they possibly can. So you'll notice here in my data, my R-squared value was 0.994. Well, remember that it's not necessarily just, that's the decimal version of a percentage. I could move that 2 places, and really my percentage is 99.4%. So that's a pretty good R-squared value. I'm pretty darn close. So what I would say about this data is that I know my regression line is a good estimate because the R-squared value is 99.4%, which is very close to 100% accurate. And also, if I looked at my picture, I'm going to go see if I can go back a slide here. Turn that off. If I look at my actual, now my little pen is on, it won't turn off. There we go, arrow. All right, if I actually look at that regression line, I also notice that all the data points are hitting that line really, really well. So that also is a good indicator that my estimate was that my prediction was going to be really accurate.